Guys, welcome back to the shop. Frank here. Got a couple questions over the years about my South Bend shaper. And I've been working on my workshop, as I mentioned in the last video, reorganizing, and I've moved the shaper over here next to the mill. And while I was moving it, I cleaned it up some. It's been covered with a preservative and anti-corrosion coating, so I've cleaned a lot of that off, and I thought, well, let me get it up and running again and maybe make a little video about it. So this is a South Bend 7-inch shaper, and they made two of these. The earlier version did not have an oil pump built into the reservoir here. You had oilers that you kept oil in for the ways. And this one is a later model. You can distinguish the two by the width of this foot here. This wider foot where the base flares out is evidence of the newer version with the built-in oiler, and they're the more desirable versions, the built-in oiler. It pumps oil up to the ways, it pumps it to all the moving components inside. So what is a shaper? What does a shaper do? What's the purpose of a shaper? They're largely obsolete today. They've been replaced by the vertical mill, the knee mill. This is a knee mill. This is like a Bridgeport mill clone. Mine is, I believe, 1970s, 80s vintage from Taiwan. And I was very fortunate to find this mill. It was a spare in a shop for years, decades, and was hardly used at all. The ways are in outstanding condition. You can still see the scraping on the ways. I mean, in the area where you would expect the most wear, the scraping is virtually factory new. So this machine has had very little use. And so I really lucked out on finding this machine, so I'm delighted with it. It's quite accurate, and it runs great. But the shapers have largely been replaced by the mill, with the exception of one or two unusual or unique functions. So this is on a little rolling stand. I put casters on it. Of course, it's designed, it could be bolted to the floor. It has a couple drawers in the stand, and this particular shaper is in excellent condition. I found it in this condition. I have done nothing to it. The only thing it's missing is the guard for the motor pulley. Everything else is as I found it. So what does it do, and how does it work? Well, there's a ram which slides back and forth on a pair of dovetailed ways, and the ram is moved back and forth. A cutter is installed in this lantern post assembly with what's called a clapper, which allows the cutter to lift on the return stroke, and the cutting edge is moved across the material. The machine vise can be moved up and down. It can be made to traverse automatically left or right. You can change the speed, the length of the stroke, and the angle of the cutter, the height of the cutter, the height of the vise. So you can make all the adjustments necessary to make your cuts. The table here moves up and down on dovetailed ways here, moves back and forth on a set of square rails ways here. The outboard end of the vise is supported by a foot, which slides back and forth on this polished surface or finished surface. It's lubricated with some oil. I just was tramming in the vise, and I got it pretty close. So you can use this hand wheel to operate the ram in and out. The length of the ram stroke length is adjustable, as well as the position of its movement. You could have a short movement out here, or a short movement back here, or a full length movement. So it's completely adjustable, and the speed is controlled by a stepped pulley arrangement. Well, there's my butchie. What you doing, huh? What you doing? It's hot outside still. You're being a good boy. Yeah. He just comes up, puts his head between your legs, and wants to get snuggled. And of course, here comes Brutus, not to be left out. He hears you talking. He's outside, and he hears you talking to Butchie. He's on his way in. All right. So, I've got a dial indicator here with the pointer on the bottom of the vise, and can just move it back and forth, and over the 3 or 4 inches of travel, it's pretty close. Here at this end of the vise, there's a 2-inch area where there's virtually, it's within 1/2 of 1,000th, but as you get further out to about this point, it drops off about 1,000th. So over the 4 inches, roughly 4 inches of travel, it's within 1,000th with even better accuracy here. The reason for that is the table is cantilevered off of these ways. Now this support here is adjustable, and you can, and the way I adjust it to level out the vise is loosen this hand screw here and basically pull up on the bottom of this table. Let this support fall and then tighten this up. And so you can get it adjusted that way, pretty close. These machines are capable of pretty good accuracy. So we can check that out. So I've got it trammed this way, pretty close. I need to tram it in the other direction. So we'll go ahead. I swapped out indicators because the other one had a foggy lens, dirty lens. So I've put a parallel in the vise. It's seated on the bottom of the vise, and that of course is what we want to measure, the parallelism, motion of the table on the ways relative to the cutter bit. So I've set it on 0, preloaded it. Well, there I'm only showing 1,000th to So basically we're seeing 2/1000ths across this half of the vise. All right, so we're going to leave it at that. I think 2/1000ths is close enough for what we're going to do here, which is really just a demonstration. See what we can do with this. So it's a piece of aluminum. Got clamped here. All right, we just scratched the surface there. We'll start over on this side, come down. Let's see if we have the right stroke length. Yeah. All right, so the stroke length is a lot longer than we need. So you can see it comes back about 1.5 inches behind the workpiece, and then, I mean, almost 3/4 of an inch in front of the workpiece. So we don't need a stroke that long. That's wasted time for that travel. You want a stroke which starts just behind the piece, maybe 1/4 inch, and ends 1/8 of an inch or, you know, 1/4 of an inch past the piece. You just need to clear the piece. So let's change the stroke length to something about, you know, 2.5 inches or something like that. So stroke length is governed by the position of this nut. This nut is on a bronze slide which moves up and down through on the bell crank, or I call it the crank that's driven by the bull gear, which is the large gear in the back. You can see that's moving up and down, and how far it moves is dependent on its initial position. So let's see if we can get it to the position to adjust it. So that's all right, so that's a little bit longer than we need, but we'll leave it there. So that's the stroke length. So now we can look at the length of the stroke, which is approximately 1 inch behind the workpiece. and at the front it just barely clears the workpiece. So it's a little bit longer than we need. You know, it's a ½ inch longer than we need, but that's okay. We'll let it go at that. But we need to adjust the position of the stroke, where the stroke occurs. So to adjust the position of the stroke, we use this. You can slide the ram, let's put it about a ½ inch past. Alright, so there the stroke runs from basically a ½ inch past the workpiece to a ½ inch behind the workpiece. Give you another look at that. Behind and in front. Okay. So now that we've got the workpiece down, clamped in the vise, the length of the stroke adjusted, we touched off on the material here, and we can adjust the depth of cut with this handle, and there's markings around here that you can use to adjust the depth of cut. Alright, so let me say something about the cutter. So normally you would use a tool bit holder like this that would hold a cutter. That's too large for this one. This one holds 1/4 inch square cutters. So you clamp a cutter in here, and this holder goes into the lantern post there. And I mean, you can run it this way, or you can run it this way. That's the normal cutter holder for these machines. Now, the alternative is to buy a piece of tool steel. This is high-speed steel, a high-speed steel blank, and grind your edge on the end of it, as I've done here. Given the appropriate relief angles, and it does away with that cutter holder. It reduces your flexibility a little bit, because you can change the angle that the holder is here for the cutter bit, and then also change this angle, so you have a little more flexibility. For example, you could have the holder, the cutter holder at an angle, and have the bit vertical or even facing the other direction. So this gives you a little more flexibility, but I think this gives you a little more rigidity. So for basic cuts, I think this is a better way to go. Certainly more expensive in terms of cutters. If you need a large variety of cutters, you're better off using a cutter holder like this and buying the necessary blanks of 1/4 inch square high-speed steel and grind your own cutter bits. Or perhaps you could even buy them. And they would be a lot less expensive to have 10 of these than 10 of these. So you could sharpen the other end, or you could sharpen both ends of these too. So this isn't a end all to be all, but it's one way of, for basic cuts, squaring stock, a cutter like this works fine. Okay, so we've got the stroke, we've got the position. We can start cutting, and we'll just take a little bit off the top surface of this piece of stock. All right, on the operator's side of the machine, there are several controls. The amount of cross feed. So this is the crank to change the position horizontally. This is a control to determine whether it moves one way or the other. And it has an arrow on the top. So you can set it to go that way, or you can set it to go this way. And in the mid position, there or there, it doesn't go anywhere. We'll leave it that way for a second. The distance it moves is determined by this crank arm here, which engages, has a pawl which engages a little gear which rotates this handle, or actually the screw. All right. And the amount of movement that it traverses with each stroke is determined by how far this crank, which has a pawl on it, which engages a gear, which drives this lead screw in increments. The position of this bolt on this control head determines how far this crank moves. So if you center this, then the crank will move very little and will advance it at a very small rate. If you move it toward the edge of this circle, then as this spins, it pushes the crank arm a greater distance. So let me just turn this on. We won't operate the feed mechanism yet, but we'll look at the motion of this crank. All right, so it's set to relatively good speed. Let's see. Okay. So now you can see this crank moving, and how far that moves is determined by its position on this rotating wheel. Okay. So right now it's not feeding. Let me stop it. There's a little indexing mark right here in the middle. It's set on 10 thousandths right now. And so we're ready. It will advance 10 thousandths each time it rotates. It'll advance 10 thousandths, and that'll be for each stroke. All right, so the next thing to do is determine the depth of cut. We touched off, and so we're going to go ahead and advance it 10 thousandths. So we'll have 10 thousandths depth of cut and 10 thousandths step over. All right, so we can see that it cut here, but it's not cleaning up the surface past that point. So we'll go ahead and start over. And let's give it another 10 thousandths. on the depth of cut. So as you can see, the whole machine is moving because it's on casters and it's not particularly stable. It's getting ready to engage the work here again. Alright, so you can see it's not quite cleaning up here. Alright, so we'll go ahead and stop it. And let's reset it. Alright, so let's take 20 thousandths off this time. 10, 20. the surface is certainly smooth. It isn't real shiny. Part of it may be the step over. I can see very fine marks of the step over. All right, let's take another run. Good boy, good butchie. Yeah, there's my brew. Good boys. Good boys. Good boy. Come here, man. Come here, butchie. Come here, butchie. Yeah. Good boys. Okay. All right, so I've got a different bit in here. Changed the angle. It's got a slightly larger radius, a little more aggressive cutting angle, which I think is appropriate for aluminum. I mean, the finish on here is quite smooth, but not shiny. So let's see if we can get a shiny surface here. Okay, we're going to move in the opposite direction. I'm going to just move the table back this way. I've touched off, put in 20 thousandths. Adding a little bit of cutting fluid. All right, so we'll stop at that point and look here, see what our surface looks like. So I'm going to say the surface finish is a little bit better over here than it is over here. I don't know how much you can see here. It's a little shinier here than here, but they're both equally smooth. So it's all about cutter speed and angle of the cut and the depth of cut. All those things determine the surface finish. So, all right, let's put a piece of steel in just to see how that does. And then we'll wrap this video up. All right, so I've replaced the piece of aluminum with a piece of mild steel. Changed the cutter back to the first one we had, which I think is a better grind for steel. And we've set the same step over and 20 thousandth depth of cut. I have reduced the stroke and reduced the speed. The speed for steel would be lower than the speed for aluminum. I changed the belt to the next pulley over here. All right, so let's we'll start it up. and start the feed. Alright, let's cut it off. Bring it back. Let's try 30 thousandths depth of cut. 10, 20, 30. Bring it back again and do 50 thousandths depth of cut. 10, 20, 30, 40, 50. See how she does with that. So we're at 50 thousandths depth of cut, 10 thousandths step over. All right, we're going to do a 1/16 of an inch, 63 thousandths. 10, 20, 30, 40, 50, 60, 1, 2, 3. All right, so this is 63 thousandths or 1/16 of an inch. This is mild steel. You stop it there before it hits the step. All right, so that's a shaper. Now, the cuts we're doing here are super simple, basically squaring a piece of material or making it thinner, taking material off a flat surface. That's the most basic thing you can do. One of the other functions, and probably one of the few functions still employed with shapers, is cutting keyways and or internal splines. Now you can put a cutter. Why won't this focus? All right, I'm going to go to manual focus here. So this can be placed in the tool holder, and it's has a small cutter bit, and this would then move in and out, and this small cutter bit could fit in an opening in a hole, for example, and cut a keyway. Now this one is not ground for a keyway cut because it's got an angle to the cutter, but you could get a bit which has a proper grind, put it in here, and cut an internal keyway, mounting the ring or disc or annular part in the vise, and then this could cut an internal keyway. Or if you reground or ground a bit to the proper profile and put your part in an indexer, you can take this vise off of this table and fasten an indexer, rotary indexer, and then using this on the inside, you can cut a gear on the outside, or you could cut a gear with a tool like this with a proper grind, or you could cut an internal spline with a tool like this. So that's the other potential use of a shaper, and some people still use it for that purpose today. Matter of fact, the guy I bought this from, it's been 3 years, was pre-pandemic, so probably in 2019 or 2020 I bought this, and he was using it for that very purpose, cutting a gear, and he showed me a gear he cut with it. And he wouldn't sell me the indexer, but I have an indexer, so for the mill, which could be attached here. One other thing I did do is I milled and I did this on the mill, a fixture plate which will fasten down to the table. Take the vise off, fasten this fixture plate down, and that would allow me to fasten, odd pieces that don't fit in the vise or whatever to this fixture plate. So it's got keyways on the bottom which engage the keyway on the table. There's a couple of keyways on the table, same size as these keyways. So you use a key and that aligns you with the table. So you can see I milled this on the mill. So that's another way to fixture items on the table without using the vise. All right, so I think that pretty much covers the operation of a shaper. And of course, this is a very small shaper. This is a 7-inch shaper, and that's the stroke. And that's how they're rated, is by the stroke. And they go up to massive 40 or maybe even larger. I've seen 42-inch, I think. I'm sure there's even larger shapers. But in their day, prior to the invention or the creation of the vertical mill, these machines were used in industry for all kinds of purposes. You can also use them vertically. You can turn the tool 90 degrees, and you can increment the height and cut down the side of a workpiece and cut it at 90 degrees to the surface. So you can square both ends and the top, flip it over, surface the other side, and you got a square piece of material. On this machine, you'd have to increment the down motion by hand by turning this every stroke. You would turn it an extra 5 thousandths or whatever is necessary. And on bigger machines, they have an automatic down feed, of course. So that's my little South Bend 7-inch shaper. As I mentioned, I bought it a couple of years ago, 3 or 4 years ago. Used it once to cut a 1/4-inch internal keyway. And that's why I have that tool for cutting the keyways. I just showed you. I made that tool. And so it's useful for those kinds of things still. It's kind of tough to do that. You can broach a keyway. At the time, I didn't have a hydraulic press. I do have a set of broaches, keyway broach set. And I've used that for smaller keyways, 1/8-inch by 1/8-inch keyways. But 1/4-inch keyway, a little bit tough unless you have a hydraulic press. So this came in handy to do that. It certainly is limited compared to the mill in terms of metal removal. It's a 1/2 horsepower versus 2 horsepower on the mill. So removing metal's all about the horsepower. And if you want to see a real shaper, a big one, look up ABOM 79, ABOM 79, ABOM 79 on YouTube. Adam Booth, he's an outstanding machinist. One of the channels I watch all the time. Fascinating. He has a 42-inch Cincinnati shaper, and it will take off huge chunks of steel. And go back and look on his channel a couple of years ago when he's taken big chips on that shaper, and it's kind of cool to watch. So that's a real shaper, though there's limited uses for them anymore, but it's a fun machine to operate, kind of old school. And I will tell you that the one thing that I think inspired me to get this shaper is my memories of high school shop class. And as a freshman in high school, I took wood and metal shop. First semester was wood shop, second semester was metal shop. And we had a shaper in the shop, but they wouldn't let us use it. The only metalworking tool they let us use was the lathe. And we had a lathe and a drill press, grinder, polisher. We had no mills, and a shaper. Yeah, I don't know what else. I don't remember what else there was. So pretty limited. And that class was focused on using the metal lathe. I think we made a hammer or a wrench or something. We made a hammer. I built a lathe, a wood turning lathe out of plans in a Popular Mechanics magazine. I think for that project, in that class, we made this wrench, like an adjustable wrench, And then the next project was to make a hammer. And I asked for permission to build this lathe. I had plans in Popular Mechanics to build a lathe, wood lathe. And the instructor said, sure. So instead of building a hammer like everybody else, I made a lathe. And I used that lathe to turn things when I was, well, I was a freshman in high school. I was 14 years old. So, and I had that lathe for, I don't know, 20 years after that. And to be honest with you, I must have thrown it away or something. For what one point my brother had it. I'd loaned it to my brother, but I don't remember what ever became of it. I don't remember what happened to it. I don't have it anymore. But it was, if I think about it, I'll post a picture of the Popular Mechanics article. I'll stick it up here, and you can see the lathe I built. But in any case, we had a shaper in the classroom. It was about this size, maybe a little bit bigger, but we weren't allowed to use it. So I saw Adam Booth's channel using a shaper, and I had to have one. So here it is. All right, that's it. How to use a little shaper. It's a lot of fun. Thanks for watching. We'll see you guys next time.